Welcome to Smarter Circuits. I'm your host, Ian Klein. This is the Shelly 1PM Smart Relay Module, and it lets you control things remotely in a variety of ways, as well as letting you set up schedules and all sorts of neat things. But that's not what this video is about. I started working on a breakdown video of this device when I realized there was something much more important to talk about that dramatically affects the lifespan of your devices. Our general electrical systems have many components, but most of them are designed to last for many years, most often decades. However, we're introducing much more sophisticated technology in our homes, and that comes with some potentially overlooked compromises. This is the inside of the Shelly device I was getting ready to explain. If you're familiar with simple electronics components, you will undoubtedly recognize many of the components shown here, most importantly, the aluminum electrolytic capacitors. These aren't the only capacitors here. There are some surface mount caps on the other side, but those aren't concerning because those are MLCCs, or multi-layered ceramic capacitors, meaning they won't do the one bad thing that these other ones most certainly will do over time: dry out. The way a capacitor works is by accumulating charges on two conductive surfaces separated by a dielectric or weak insulator. The charges build up until they reach the point where they breach the dielectric and allow motive electrons to pass through the electrode. The more charge you can build, the more you can store. Another drawback to this, besides drying out for any electrolytic cell like your car battery, is that over time a layer of oxidation builds up inside and prevents the flow of electricity, slowly killing the cell. This is reversed or slowed to some degree by the constant cycling of charges, but the end result is the same. In order to gain the high voltage and high capacitance we need for certain applications, we have no choice but to sacrifice a small amount of durability. This affects a lot of devices. Some of those will be long obsolete by the time the caps fail, but some of them I rely on to keep turning my lights on and off. Most electrolytic capacitors have a passive shelf life of about 2 years. This is extended manyfold when these devices are in use because of the way they cycle chemically, but either way they wear down faster than most of the other components they usually live with. This is true for other components, especially ones that are sensitive to being unused for prolonged periods of time, but the electrolytic capacitor is among the most common, and for a very important reason. Most devices that rely on power that isn't noisy will have at least a couple of these electrolytic capacitors in them because they're easy to make and fit the requirements for some of the more abusive applications. If you have a fluctuating supply of power and you need to smooth it out, you simply put something in line that can hold a charge and discharge it evenly at a level that meets your needs. But how long can these components really do their job reliably? Well, that's a tricky question, and even when a manufacturer says 5 years, it could be 30 before a critical failure, not something to bank on, or it could be less. A lot depends on the design of your device and what sort of environment it lives in. This isn't an issue if the device you're using has enough separation of concerns. This combination of components will do all the same things that this smart relay will do. But if the caps on the power supply fail, I simply replace the power supply, and my other components will be just fine. I'm not saying the other components can't fail for other reasons, but even though I love these Shelly devices, it kind of sucks that we have to toss the whole thing away if only one of its component parts fails. It will likely still last many years, so I accept that I will have to replace it sooner than the average home electrical component because it should only be marginally more frequent, but it's something to consider. And for more than just smart devices. We throw a lot of stuff away because only a small part of it fails. But that's a topic for another video. In the next video, I'm going to show you how to make this device and use it to control circuits from afar. I do hope you enjoyed the video, and of course, if you did enjoy it and haven't already done so, please do subscribe to the channel. If you want to know what's going on between episodes, you can follow Smarter Circuits on Twitter @CircuitsSmarter or on Facebook, and if you'd like to help make more and better videos possible, consider becoming a patron on our Patreon page linked below. Thanks for listening to me ramble, and I do hope you'll join me for future videos as I continue building smarter circuits.